The solution to a 3-mark question that was given as part of the sample paper by CBSE in 2019 for class 10 math. Question number 19, this question had two alternatives. We're looking at solution to both the alternatives in this video. Both these questions appeared from triangles. Reasonably interesting question, medium difficulty question. Let's start with the first of the alternatives. Angle 1 equals angle 2, which is what is given, and triangle NSQ and triangle MTR are congruent triangles. They said these two angles are equal. They said two triangles are congruent. Let's mark those vertices. Triangle NSQ. So I'll circle the vertices for this NSQ and I'll draw a square around it. Triangle MTR. These two triangles are congruent triangles is what they've said. What we need to prove is that triangle PTS, the small triangle, and triangle PRQ are similar triangles. They mentioned these two are congruent. We need to prove these two are similar. Proving this is actually a 4-step process. Let's get started. Let's start with the first information given to us. They said angle 1 is equal to angle 2. I'm going to pick triangle PTS. In triangle PTS, angle 1 equals angle 2. If in a triangle, two angles are equal, correspondingly to opposite sides will be equal. So side opposite to angle 1 is PT, side opposite to angle 2 is PS. So we can establish that PS is equal to PT, right? This is result number 1 that you have got in step number 1. Let's go to the second information given, that's step number 2. They've said two triangles are congruent triangles. Congruent triangles, we know corresponding parts of congruent triangles are equal. So corresponding parts of congruent triangles by CPCT, I am going to establish two angles to be equal. Which two angles? I'm going to pick angle NQS. Angle NQS is equal to angle MRT. Let's mark those, right? Angle NQS, this is that angle. I'll call it as angle 3. And angle MRT. So this I'll call it as angle 4. So angle 3 is equal to angle 4. But hold on for a minute. This angle 3 and angle 4 are also part of this triangle PQR. What would these angles be in triangle PQR? NQS is going to be angle PQR. And MRT is going to be angle PRQ. So in step 2, we have established that angle 3 equals angle 4 by CPCT. But these two angles are also part of triangle PQR. Therefore, we can say angle PQR is equal to angle PRQ. So step 2 done. In step 3, I'm going to just repeat what we did in step 1. In triangle PQR, two angles are equal, which means correspondingly to opposite sides should be equal. The side opposite to angle 3 is PR, side opposite to angle 4 is PQ. Therefore, we can establish in triangle PQR, exactly as step number 1, we can say that PQ is equal to PR. The next step should actually give us the answer. I'm going to find out the ratio between PS and PQ, right? PS by PQ is the ratio. But PS is equal to PT, so we can write PS or PT, it's going to be the same. PQ is equal to PR, so instead of PQ, we can write PR. So PS by PQ will be the same as PT by PR. PS is a side of the smaller triangle PST. PQ is a side of the larger triangle. The ratio between these two is the same as the ratio of two other sides of these two triangles, PT and PR. That's what we are saying. So two sides of these two triangles are in proportion. If we can establish that the included angle between these two sides is the same for both the triangles, then by SAS, we can say that these two triangles are similar. We know the sides are PS and PT. The included angle, therefore, is going to be equal to angle P. In the larger triangle, PQ and PR are the two sides which are in proportion to the corresponding sides of the smaller triangle. The included angle is angle P. So the included angle is the same. Two sides are in proportion. By SAS, we can therefore establish that triangle PTS is similar to triangle PRQ. Right? Quickly summarize these 4 steps in a printed form in less than a minute before we move on to the second alternative. First step, using the fact that angle 1 is equal to angle 2, we've established PT equals PS. Two angles are equal, correspondingly opposite sides would be equal. Right? Done. Second, we are going to move into this information that these two triangles are congruent triangles. By the fact that corresponding parts of congruent triangles will be equal, we can establish angle NQS is the same as angle MRT. This is angle 3, angle 4. Then we went about establishing in this step, these are also angles as part of triangle PQR. In triangle PQR, NQS is nothing but angle PQR and MRT is nothing but angle PRQ. So we can establish angle PQR equals angle PRQ. The next step, third step, you're going to repeat exactly what we did between angle 1 and 2 as the same as what we're going to be doing with angle 3 and 4. Two angles in triangle PQR are equal, which means correspondingly to opposite sides should be equal. PR is equal to PQ. Result 1, result 2, we're finding out the ratio between PT and PR. PT and PR will be the same as the ratio between PS and PQ because PT equals PS and PR equals PQ. So we established that the ratio between two sides of these two triangles, PS by PQ, is the same as PT by PR. The included angle is the same for both PS, for the triangle, for the sides PS, PT and sides PQ and PR. Included angle measures the same, which is a common angle, and the two sides are in proportion. By SAS, we can say these two triangles are similar triangles. Let's move to the second alternative. Second alternative, being given triangle ABC. AD is the median, which is the midpoint of BC. We need to show that AB square plus AC square plus AC square is equal to 2 times of AD square plus BD square, 2 times of AD square plus BD square. This is also from triangles. It's a beautiful theorem which is called the Apollonius Theorem. This is usually used to compute the length of the median AD. Let's get started. D is the midpoint because AD is the median. Therefore, BD will be equal to DC. That's the first rule or result we are establishing. AE is the altitude to side BC, which means AE is perpendicular to BC as given in the diagram. Now let's look at right triangle AEB. In right triangle AEB, the hypotenuse AB square of the hypotenuse AB square equals AE square plus BE square. Let's run through the same thing with the second right triangle that we have. AEC is the second right triangle. The hypotenuse is equal to AC. AC square is equal to AE square plus EC square. Note one thing, D is the midpoint, E is not the midpoint, though it appears that way in this diagram. We need to prove that AB square plus AC square equals something. AB square and AC square are the left-hand sides of these two equations 1 and 2. So let's basically add these two equations so that the left-hand side is done. So left-hand side of what we need to prove is obtained by summing up these two equations. The left-hand side of the sum is the left-hand side of what we need to prove. The right-hand side is this. So at some level, we need to get this value, this expression, the sum of these two values to be equal to 2 times of AD square plus BD square. When you sum these two, AE square plus AE square will leave us with 2AE square plus a BE square plus an EC square. AE is nothing but, if you look at right triangle AED and right triangle AED, right? AE square will be equal to AD square, which is the hypotenuse, minus ED square. So I'm going to write this AE square as AD square minus ED square. So we wanted 2AD square, we got that part. We need to add, subtract all of these things and probably make this as BD square, 2 times BD square. That's objective. Let's set about doing that. This BE is nothing but BD is a median. D is a midpoint. So BD is going to be equal to DC, that we have established. So we'll write it in terms of BD. BE is nothing but BD minus ED. BE is nothing but BD minus ED. In the right hand side, we have EC square. D is a midpoint. So we can write the CE or EC as ED plus CD square. So this is equal to ED plus CD the whole square, right? This is AE square written as AD square minus ED square. BE square is written as BD minus ED the whole square. EC square is written as ED plus DC the whole square or CD the whole square. So this is 2 times of AD square minus 2 times of ED square. Let's expand this. We'll have a BD square, A square plus B square minus 2AB plus ED square minus 2 times of BD into ED. This expression, let's expand it. This is going to be equal to another ED square plus CD square plus 2 times of CD into ED. That's what we have. We have 2 ED square here. There is an ED square positive here, ED square positive here. So these get cancelled. We know that BD is equal to CD. So instead of the CD, if I replace it as a BD, we have 2 BD into ED in the negative here and 2 BD into ED in the positive here. So these two will get cancelled. So what we are left with is 2 times of AD square plus BD square. We know BD is equal to CD. So the CD can be replaced with another BD. So that's going to be equal to plus BD square. So that results in 2 times of AD square plus BD square, which is what we set about proving. Quickly summarize this entire thing in a printed form. By adding the left hand side, that will give us with AB square plus AC square, which is the left hand side of what we need to prove. Correspondingly, we'll have to add the right hand side of these two equations. So what we'll have is AB square plus AC square equals 2 times of AE square, 2 times of AE square plus BE square plus CE square. Forget this left hand side, we're just going to focus on the right hand side. So AE using right triangle AED. In right triangle AED, AE is nothing but the square of the hypotenuse AD square minus ED square. So that is your AE square. BE can be written as BD minus ED. That's what we have done. CE can be written as CD plus ED square or DC plus ED the whole square. Expanding these terms, so this becomes a 2AD square minus 2ED square, BD square plus ED square, A square plus B square minus 2AB, which is A square plus B square plus 2AB. The 2ED squares will get cancelled with the 2 positive ED square. BD is the same as CD, so BD into ED or CD into ED will get cancelled because one is positive, the other is negative. So we have 2AD square plus BD square plus DC square. D is the median, D is the midpoint, so BD will be equal to DC or CD. So this can also be written as a BD square. So 2AD square plus BD square plus BD square, which is nothing but 2 times of AD square plus BD square, right? If you're comfortable remembering proofs, I would have gone with alternative 2. Otherwise, alternative 1 is what I would have solved in this exam. Before you leave, do 2 things. Sign up at online.maxtute.com to get started with your CBSE online coaching for class 10 math. Takes all of 3 steps and less than 5 minutes to get started. And subscribe to the channel youtube.com/maxtute and spread the word among your friends and classmates.